With the amount of material layers you can end up with when working on objects in view, it can become a little cumbersome and slow your scene down a little bit at render time and also just the performance overall. You can also run into certain issues with dynamic population and scale changes when moving from a material over to an ecosystem, especially in terrains, having so many material layers. So what I want to show you is how you can condense those materials uh, on basically any object. We're going to be using terrains and condense them down into a texture. So first we will need something in the scene. What I want to start with is just loading in a procedural terrain. And I'm going to modify the atmosphere I have, bringing the sun up a little higher in the sky, and just kind of rotating it around so we can see what's going on a little bit more. And we're just going to add a few materials to this, edit the terrain, turn off zero edges, and we're just going to kind of go through clicking the new button to find a nice terrain we can work with. Just randomly generating one rather than painting one out, and just letting the procedural create the overall shape. So let's start by loading in a material. And under landscapes, there's a default material, one that's called default. Go ahead and load that in. And if we just take a look at a quick preview, we can see the material that's generated. And the coloration might not match the scene I have or the lighting so much. So I'll go ahead and just bring down the sun. And I do have auto exposure on at the moment, which can also interfere slightly with the look of the scene. I am going to keep it on at the moment. If you double click on the camera, you can see the advanced render options where there's the auto exposure and the natural film response. But if we take a look at the material, it is a mixed material. So it is made up of what we have is grass and then kind of a darker rocky type dirt texture being distributed by the grainy fractal, and then also some settings in the influence of environment. So what I want to do is take this rock, and I'm going to increase the bump a little. If we edit the function, we'll actually see that there is no bump. I do want to connect it to the output that we have generating the color. So just connecting it to the brightness and contrast, be able to add a little bit of bump to it. And that should help increase the depth and realism of the texture. Now, since the base layer and the main primary layer at the moment is a mixed material, you cannot add additional layers on top of it. It is grayed out. Within the distribution of material 1 and 2, you could create additional layers for the mix. So if we wanted to add a layer on top of this rock, we'd be able to add one on top, and then we would still always see the grass exactly where it's at because it's a mixed material. There is a trick, however, to add additional layers on top of a mixed material. And what you can do is with the material, the main base material stack selected, so what is called default, select that and check ecosystem. What this does is creates a new stack, a primary stack of 2 layers a layer on top of a mixed material. And it's also called default. I'm going to go ahead and just call it main terrain, just so it's separate. And it carried over the name of the previous material to create the ecosystem name, which is also called default. We're going to end up deleting this. But now with the ecosystem there, we can add a layer. So with the mixed material selected, we cannot add a layer. But once we add in the ecosystem, kind of allows us to go a little bit beyond the standard features and now add in an additional layer. So under material layers, let's go ahead and select brown sand. And now we can select the ecosystem, delete the layer, and we now have a layer on top of a mixed material. So that's a neat little trick you can do to get that on top. And now we'll be able to see that brown sand showing up over the top of the mixed material. And we don't need to worry about the distribution and breaking down all the layers. Now this is controlled with an alpha. So if we edit the function, we can take a look and see the alpha channel, which is a grainy fractal. A lot of these layers are materials that come with View 7, using a lot of the new nodes, the grainy fractal being one of them, along with the terrain fractal, and those two were added in version 7. So if you're using version 6, you can use just a simple fractal and still be able to achieve something very similar. It just might take a few more steps. So we could edit the transparency, which is basically what the alpha channel is, and modify that if we wanted to. And there's also an alpha boost, which adjusts the overall influence of that alpha channel, whether or not we want to increase the contrast of it or decrease the overall amount gained from it. So if we increase the alpha boost, we're going to notice a lot more of the sand showing up. And I do want to add a few more elements to this. Go back to the material. I'm going to add another layer. And I'm going to select the grass and forest material layer. Now, the material layers are guaranteed to be simple materials. They are meant for adding additional layers or changing mixed material layers. Once you get into the other presets, landscapes, rocks, you might end up with some that are simple materials, but some will also be mixed materials. And you can't add, in most cases, a mixed material on top. We'd be able to switch this to a mixed material, but it's not necessarily going to work correctly because of the way it was set up. I am going to change the alpha boost to 0. So now we're really going to see just the grass and forest because there is no alpha programmed into it. But we can go over to the environment tab, and what I want to do is just make this show up on flatter regions. So we can bring the slope range up, and we'll start to see patches showing in the distribution. And I'm just going to increase the fuzziness amount. I'll just type in a manual value of 8. And I might want to increase the range just slightly. I don't want a full coverage, but just enough to kind of have it peeking through. And we'll go ahead and do a little bit of preferred orientation. Increase the tightness slightly and the fuzziness. And see that layer now on top of all the rest. And you could basically do this an endless amount of times, just adding tons of layers on top of additional layers. Of course, every time you add a layer, it will reset scales. And that is one thing to keep in mind. And we can also set individual mapping modes for each of the layers, where we can see we have uh, the current mapping mode. I also want to note that the effects and this panel on top is a global control. The top material is the one that's going to be controlling whether or not cast shadows, receive shadows, only shadows, the indirect lighting, anti-aliasing, one-sided. So any changes you make to the top material layer, it will affect all of them. So if I turn off receive shadow, that will turn off receive shadow for all of the layers. So that is a global control and a restriction, unfortunately. So you can't really go into individual material layers and set that up. But let's just kind of pretend this is a much more complex material and something we really want to condense down into one material. Now, the only real way to do that, besides mixing all of the functions together, which actually is possible, you could create one material that contains all of this information because everything available within the Environment tab can be accessed and controlled within the function editor. So if you really wanted to have one global function for all of the materials, you could do that, but it's going to perform very slowly, take a little longer to render, and setting that up may not be worth it. The mixed material itself, the distribution, all of that can be set up. It is nice having some of these preset controls, though, which makes this technique a little bit better to use. So instead of having this material where now, let's say we want to add an ecosystem and we don't really want to have to continue rendering this material out, and the more layers we're going to add to the material, the more problems we could potentially run into. And ecosystems will also tend to behave a little differently when you have this sort of a setup for the material. Especially with dynamic population, which is a feature part of 7.0 and up. If you're a version 6 user, dynamic population isn't available. But it basically generates ecosystem instances at the time of render, just whatever's in the camera view. I have noticed, at least before version 7.5, that using dynamic population would sometimes shrink the ecosystem instances and have some really horrible outputs when you have a really complex material setup, especially when you're kind of tricking View to put layers on top of mixed materials, which typically isn't part of the program and not a feature that's really built in to do that. Although it usually behaves pretty well. It's just when you get to the ecosystems that you might run into trouble. So one thing we could do is, instead of using, like we did earlier, the camera projection to project a render onto the terrain, what we can do is render out the entire material. Now, there are some details we're going to end up losing, specular values, really depending on how complex the function is. If you have luminance map set up or anything connected to contrast or loom value in any specific setups, that way with the different highlight modes as well, it might not carry over very well. But for the color and bump channels, the main channels, and the rest of it, we can just kind of create new maps. So let's take a look at how we can do that. If we edit the object in our procedural terrain, because it is a procedural terrain, we cannot export it directly from the terrain editor. One thing we can do is go to File, and if we go to Export Object, we can bypass that setting and export 3D geometry, which will do a conversion automatically. With this export option, we can choose to generate color map and bump maps. And now if you're using objects imported in, or any object, uh, basically it would have to be a baked mesh for view object. But if anything's imported, you could also have baked illumination maps. So you could include that within it. And if there's any alpha setup, that can also be included in this. Now, there are two options for the main file format. You can choose which 3D object type you'd like to export, and then the mesh resolution. Because this is a procedural terrain, the resolution can go pretty high. And then you have some different options to export the main geometry. Since all we really want is the color maps and the bump map, you can take the mesh resolution and just make it as small as possible, which is not going to impact the bump or color output. So the main thing we need to pay attention to is the texture map scale. Right now I have it set to 1024, which would be also by 1024. So it's a square image, and we have a square terrain, so that's going to fit. One thing to keep in mind is it will render out each of these materials. And the higher the resolution, the longer it's going to take to render. And unfortunately, this export option is a single core process. So you'll basically be exporting and only rendering with the one core. So I'm working on a quad core, and only 25% of my CPU will be rendering this output, which is going to take a lot longer to bring it out. Now, depending on how much post work you want to do, and really because of the time it can take to render this, uh, the method of camera projection can sometimes be a little more useful. But if you really want just a flat map projected down and something you can just edit, you really just want to have something to work off of, which is really the best way anyway, because not everything's going to look realistic that comes out of you, and it might need to be tweaked color-wise and adding detail in post anyway. But what you can do is give yourself a really good reference using the controls from the environment, the mixed materials, to give yourself a nice starting point, and then just scale the image size larger and work from there on the maps. So we're going to choose the color and bump maps, and I'm going to go ahead and just set up a folder, and we can save the object to it, and then the material maps will also go into the same folder. I'll just choose the 3ds format. So we've got the color map, bump map, and the bump map I do want to be a little higher res. So I will use the TIFF format for the bump. Just stick with the bitmap for the color. And go ahead and just click OK, and it's going to render out the material and create two texture maps, both 1024 by 1024, one for the color and one for the bump. And then what we can do is map those back onto the terrain. And working with a procedural terrain works a little bit differently than a standard terrain. So we'll take a look at a standard terrain in just a sec, which actually gives us a little more options for overall export and generating some additional maps. And now, if we take a look at the color output, it's wrong. This is going to be useless. The reason for that is because the procedural terrain, when you're exporting with this export method and not using the terrain export from the terrain editor, which is impossible when you have a procedural terrain, what it ends up doing is generating the UV maps, and what we're seeing is based on the UV map for the geometry, and that might be because of the overall resolution that I chose. So it does work a little bit differently with procedural terrain, and that is probably just the geometry that is causing these extra errors. So I'm going to once again just go ahead and export this with a slightly higher geometry, see what happens. But otherwise, we're going to take a look at what we can do to improve the output. So we'll go back and export this object, increasing the resolution of the overall terrain. So this is the output we end up with now, which is, once again, wrong. And the original one was even closer than this one. So uh, what we need to do is basically create a duplicate object for the material. Because our goal is to keep the procedural terrain. We don't want to remove that. All we want is just to bake the material. So what I want to do is copy this object, paste it, and now if we right click, edit the object, and go into the terrain editor, what we can do is first increase the resolution because we are going to have some additional options with this. And I'm just going to bring it up to 1024 by 1024, and we're going to convert this to standard. And apparently crash the program. So I'll just go ahead and reopen that. And since I didn't save that scene, I just kind of recreated it, something fairly close to what it was before. And I believe I know what it is that crashed Vue in this case. And because we had created a duplicate object, what it did was transfer over the material to the new object. So we had two materials with the same name. Now, there's a huge difference between scale sizes between a standard terrain and a procedural terrain. And I think the error was probably due to that material transfer. So I think the easiest thing to do is just to create a separate scene that we can save these materials from and go back to this one. And that way we'll keep the same terrain in the scene and hopefully avoid any problems. So I'm going to make sure I save it this time. So I've just called this material export proc for procedural. And what I want to do is save it again before I make the change. And then we're already working in the modified file. So I've just called this proc or procedural convert. And now what we can do is convert this over without that duplicate. And this could also be caused by the material naming within the material, one of the reasons that caused the crash. So one thing I am going to do is modify the names of the materials. And I am going to keep the stack called default just because we did kind of trick Vue into doing this setup. So we'll start with that. We'll go ahead and just save, and now go into the terrain editor and hopefully not run into the same problem. And I did go ahead and test it to make sure it didn't crash first, which is you might have just saw that jump really quick. I'm going to go ahead and just cancel that, go back, increase the resolution, and now convert it to a standard terrain. Click OK, and there we go. So now that is ready to go. I do want to note that the way the influence of environment is going to affect a standard terrain will be different from the procedural because of the terrain definition. since the procedural terrain has more geometry, the environment tab, working with the slope primarily, could impact the look of the material. But for the most part, we are just looking to get something to start with, and this will still give us a good starting base layer, because really we just want to paint it outside of the program and create our maps. So what we can do now is, instead of using the file and export object option, we're going to edit the object and use the export terrain option, which gives us a little more control. And there's two different ways we can export the terrain. We can either export it as a 3D object or as an image file, which will give us a displacement map. That displacement map can also be used to create a normal map. If you're going to be using normal maps within another application, if you want to export this to another application. So that's a really cool way to be able to create a normal map. If you're not sure how to do that, there is a free tool available from NVIDIA that works with Photoshop that will create normal maps from height field based images or displacement maps, so grayscale images, and it will automatically generate normal maps. So that's a really helpful tool, and you can get that from NVIDIA's website. Just type in normal maps into the search on their site, and you should be able to find it. That will only work with the 32-bit version, however. So let's go ahead and include that displacement instead of doing a 3D object. We're going to generate our materials, which are going to be, let's just use the bitmaps once again. We'll do 1024 by 1024, which is also the scale of our terrain. And the size of the image that will be exported is going to be whichever resolution you have set in the terrain editor. So that is the complete control for that displacement map output. And I'm just going to choose the directory, and I'm just going to call it terrain, which is the default based on the object name, and make sure that you save the type as the Photoshop file if that's the format you want to use. I am going to use 8-bit in this case. A displacement map you really want to be 16-bit. There's a lot of reasons for that, but because I'm using the Photoshop export, I'm really just concerned about speed right now. I'm just going to do the 8-bit, and sometimes 16-bit will cause a few problems with the mesh resolution slider, where it still works when you save 16-bit, and that can cause some problems. So we'll go ahead and start from there. Just click OK, and now it's going to do what it did before and render that out. And I also want to note that whenever you save in the image format, or at least Photoshop format, if you look in the lower part of the screen, the lower left, where it's showing the progress, normally it'll say the format it is saving in, which would be, if it was a 3ds file, it would say exporting 3ds object. Well, in this case, even though we're exporting a Photoshop file, it will say exporting an OBJ file, so OBJ object. And basically, it might just be short for object, but then it would be exporting object. So for the most of it, just don't worry about that. You can ignore it. It'll still export the image. It hasn't, or it's not generating an object file that will be saved unless that's something it's doing in the background to generate the image. So I'll just let that finish up, and then we can take a look at the maps. Okay, so this is our color, which is generated correctly. And because of the lower resolution on the terrain, we do see less detail around the blending. But overall, this does give us a really good starting point to create a material from. If we take a look at the bump, because I saved it as a bitmap, it is an index file. Index mode and not grayscale. TIFF would create a grayscale, and some of the other formats would also do that. And then if we take a look at the displacement, we can see our height field, which also won't be as detailed, although there is a way to generate a much more detailed procedural map and render much faster without using the export. We'll take a look at that in just a minute. So we can generate our maps from these files as a starting point. I do want to note that if you take a look at the edges, you may need to crop that, and it looks like it's really just a problem on the color map because the displacement seems to be okay. It doesn't cut off. Neither does the bump. And really the best way to find out is probably just going to be to overlay the images. But that might be because of the way the UV is generated. Once again, because we are using an export command for all the geometry, so we might just need to go in there and modify it. There is one more thing that I'm looking at right now, and it looks like it might be shifted slightly. So I am going to just kind of take a look, go ahead and copy, actually we'll go ahead and copy the bump map, paste it onto the color. And that's just because the navigator was viewed a little differently, so really they weren't off at all. So we can see them matching up, besides my me not paying attention to the zoom amount. So now we have our bump map, which we can modify, and our color, and either a base to start with or a way to condense our materials, which would work better with a much higher resolution. Really, if you have a much larger terrain, there are better methods to dealing with that. So I'm going to go back to the procedural, and I'm going to select the object, reset this material, and map those images on. So editing the function, we can go ahead, delete the current nodes, add in texture map node, or a projected texture map will work for this. Set it to flat vertical, and load in those materials. So I have the color, click once more, and I do look like I have a little bit of an OpenGL error. I'm not sure if that's showing in the recording. Okay, go ahead and grab, create another texture map, load in, this time, the bump, and we can connect the color to the color output, the bump to the bump output, grayscale for the bump, color output for the color. And I will note that the intensity of an image on the bump channel will cause some issues, so you will need to reduce the output. We'll do that in just a sec, but first of all, bump modes or bump maps and also highlight maps, you should always use one of the interpolation types, or at least bilinear, to get some nice smoothing. Otherwise your bump map's going to look terrible, and it's going to create some really interesting shapes. Bicubic will basically ignore the anti-aliasing. Normalized sometimes will work, but I usually use bilinear. Now, to get this to stretch and fit correctly to the terrain, we do need to change this to the object parametric mapping mode. And we're going to see if we need to make any scale changes, because we might need to modify the position and sometimes the orientation of the material. And now you can see that bump is just looking terrible. Let's go into the material, and what you want to do is reduce the depth amount because, like I was saying, images really uh, you do need to reduce the bump amount. We'll do 0.1. And I also want to note that the OpenGL preview probably won't be right. Uh, on a standard terrain, if we were to map this, it would be inverted on the y-axis. So basically, if you wanted it to show up correctly in the OpenGL, you would have to edit the map, flip it vertically, but then it would also render incorrectly. So we'll just take a look, and we can clearly see the OpenGL is off. We just want to make sure that the placement of the map is showing up correctly, and we may need to modify that color because of that strange edge that's showing up. But it does give us a good reference and starting point for the scene. And I do want to make a quick note, just referencing the axis that is used for the output. When we edit the object and in the terrain editor, up at the upper top, upper left, you can go between the free viewport, being able to rotate around, and the top view. Now the top view, the y-axis is up and down, really depending on, of course, which coordinate system you have set. Right now I just have it on the default where the z-axis is up, and then y and x. And in this case, y goes up and down, and x will go horizontally. So going across, and the image is set up that way as well. And because of the way this material was created, it might be difficult to tell whether or not the map is showing up correctly, but it looks like it is a little bit off because we did have that forest material, which is the bumpy darker green, showing up on flatter surfaces, and it doesn't look like it's matching correctly. So one thing I'm going to try to do is first switch our mapping mode in the material to automatic. And if that doesn't work, we'll just need to modify the material manually. Basically just either flipping it on the vertical or horizontal, and other than that, no other changes should really need to be made. Once again, because of that rim that is showing up, you might need to modify that. And what I did was just load in really quick uh, the original material, which is rendering right now. And it does look like that image map was showing up pretty much correctly. So there shouldn't be any changes that need to be made. Now, because of the resolution changes and the overall quality differences, if you want to still have a few of the layers showing up, and you just want to render out maybe some of the base layers or underlying layers, what you can do is go into the material, and all you have to do is select the layer and change the alpha boost. And when you move the slider all the way to the left, negative 100%, it basically triggers a transparency. And now, depending if the alpha has a lot of gain in it, what you might need to do is increase the transparency to 100%. And that way, the material isn't showing up. Or you could just delete the layer temporarily, of course, having another scene for that. But now, with the scene loaded in with the material mapped from the texture map render, we do have the ability to now work with a much simpler material if we want to start adding ecosystems and building up from there. Obviously, this is a very low resolution for a material map. And if we need to create alternate variations of the specular color, and in this case, uh, whenever you reset a material, it does take the highlight and set it to black, and also does a way too shiny of a setting, so it's way too glossy. You can just adjust those highlight values. One thing you can do is set a variable highlight, edit the function, and connect the highlight to the bump output, and that can create a pretty nice variation. Once you do that, you do typically need to increase the global intensity in order to get enough out of the map. You could also connect the highlight color to the color of the image, maybe something a little bit brighter. A couple of different things you can do with it there. So if we were to modify the map in Photoshop, since this is our starting point, what we can do is increase the scale to give ourselves a better resolution. Just going to image, image size, set our new scale, and then the resampling. There's a lot of different methods you can use for this. Because we are going such a wide range throughout the material, some of these methods will help reduce the noise that shows up from the procedural, where in this case the grass is very noisy. So we might want to use the bicubic mode. The setting for bicubic smoother, best for enlargement, might not work correctly. It might carry over too much of the grit and the grain. So you really just kind of have to try it out. But for the most part, I mean, you're going to be editing and modifying the map manually, so it doesn't matter too much. We'll go ahead and try bicubic, see how that looks. And then we can run post-process on this, apply images, overlays, and end up with a much better looking image map directly on top of that. Now I'm just really quick going to improve this color map and map it on top of that terrain. What I have is that the grass image I was using earlier in the training, and what I want to do is just put this on top of the current layer. I'm going to set it to hard mix, or actually hard light, and that gives us a nice contrast, still bringing out some of the image. But also what I want to do is take the bump map and just in the normal mode we can see just this image applying to the bump. But if we set this to lighten, we can get some nice edges, something that looks a little bit better. You can use screen to add more of a transition, but we still have some harsher lines that way. And using some of these different blend modes, you can use the bump to really help create certain masks with this. So we could go through and see what other ones look like, create some interesting variations. But I am going to use the lighten mode. And now if we want to create, maybe add some additional detail around these edges, we could paint that in, distort the image map, and then probably what should be done is taking a clone stamp tool and just going around the edge of that original color map just to remove those lines and distortions that are showing. So I'm going to go ahead and save this out, and the bump map will also need to be modified, improving the quality since we resampled it, changed the scale. So we'll go ahead and save this out really quick and we can go over to view. And just a really quick way to modify that bump map. I'm going to set this to normal mode and then select that grass layer, go to image adjustments, do black and white, and now we can create a bump from this image map, or at least a layer we can overlay on top of it. We do multiply, maybe adjust the levels, and get something that blends a little bit better. So now you can see much more of the bump showing up here. So you really just obviously want to mess around with it, make it look a little better. So back in view, we can edit the material and just load in those new maps. Select that new bump, which will also affect the highlight. And because the highlight mode, typically you want a much harsher look for the highlight or a higher contrast image, I am going to add in a new image and just use the existing image for the highlight and load in the new bump and connect that. And now we can take a look at a render. Just render something fairly quick and small. And because the procedural terrain is adding a lot of detail to this, and that highlight map is rather low quality, I should probably just use a filter and use the new map. I am going to actually just go ahead and delete that highlight. Make sure the bump has bilinear set and adjust the highlight overall. And we're still seeing a lot of roughness. Mainly that's just because we have a procedural terrain where there is a lot of roughness within the fractal. And because of the lighting settings, the diffusion is showing up rather intense. So we'll switch this more to ambient, brighten up the scene a little. And I'm going to go ahead and render that out. And it does look slightly better. But of course, once again, that bump coming from the procedural terrain is really, really intense. So whether or not I want to modify the material a little bit more to get rid of the intensity, or I could go in and decrease the roughness of the procedural. So we select the procedural within Terrain Editor Procedural tab, go into the function, select the fractal, and just bring down the roughness a little. It shouldn't destroy that much of the overall shape of the terrain, just the really fine details. Another thing you could do is just increase the smallest feature size. So that does look a little bit better. Once again, smallest feature size will take the smallest part of, or the smallest details from that terrain and increase their scale or limit the scale. Another thing is the image map itself is rather large compared to how much of the terrain we're viewing, or rather small compared to the terrain size. So I'll just go ahead and zoom out, and maybe we'll increase the height. And now we have a pretty nice underlying layer that we can use and start building an ecosystem onto. And we don't have all of those other layers conflicting with the rest of it. I'll just really quick load in a maple tree. We'll make it go a little more towards the bottom. Turn off decay near foreign objects. So it's going a little more towards the edges. And it looks like there might be a slight problem with the lowest point of the altitude range. So we just might need to take the altitude range, even though we're set by object, you might need to go a little bit below it, or set it to an absolute mode. And we'll just change some of these settings, repopulate. Maybe do a little bit more, reduce density, just to have something quick showing up here. And then in the color, I'm going to set the variable color and change, since the maple tree is a little too pale blue, it has more ambient light color than actual leaf color. So we'll set that variable color to make it more of an even tone, but also keep in mind that will modify all materials. So in this case, it'll also include the bark. So as we start building up the scene, we have a nice underlying layer now where we can just focus on the ecosystem, where it's nice and condensed, and really just work on the image maps. If you want to bring them into another program and work on the maps there, it could be much easier if you have a program you can paint in, something like ZBrush, where you can have the geometry and also work on the color maps and bump maps, additional maps for the terrain. But if you do take a look at the bark on those trees, they're turning to red now because of the green overlay, and it also modifies not only the leaves but also the trunk. So that overall color change might be best done in post rather than doing it directly within view. Although we do have the ability to remove the color variation this way, which is really helpful. So I'm just going to fill this in a little. We'll zoom out. And that looks a little bit better. But we still have that nice layer underneath, and now we can add the ecosystem. Now there's one last thing I want to show you in here, and that is how we can export the procedural height map. Right now, go to edit the object. Of course, that export terrain is disabled because it's a procedural. Now, using File and Export object, of course, does not give us the ability to export an image. So what we have to do is find a way to render just the procedural. It's actually pretty easy. And by not using the export functions, we can use all processor cores. Or render it on a render farm. In order to do that, what we need to do, first I'm going to just get rid of this ecosystem, delete that layer. And what I want to do is create a flat object. And what's going to work best is a box. I don't want to use a plane because overall, the geometry, or basically the scale and vector settings of a flat plane, are different from the standard geometry within view. So I'm going to use a box instead of using a plane. And we can scale this up. And now because we had that procedural terrain selected, it is copying over that material. We're just going to reset it for now. And the overall size of this shouldn't matter because we do have a object parametric terrain. If you had a world mode terrain, you will need to match the scales, and you can set that up with a graph. You do not need to worry about the up and down, or in this case, the Z scale with the settings I have. So if you want to set up a simple graph for that, to match the size, what you can do is how I access that. Okay, I have the cube selected. In the lower right, we can edit the object graph. This is probably one of the most powerful features being tied into the function editor. The function editor is the core of the program. Everything in one way or another runs through the function editor in different ways. So knowing how to use it is really important, and graphs give us the ability to make special links that aren't available. Now this graph option is only available in version 7 and up, so if you're using version 6 or version 5, you don't have this ability, and you have to kind of size it manually. What I want to do is add in, if you right click, go to Add Input Node, External Dependency. What we can do is select the procedural terrain and its size. This is going to output a vector, x, y, z. Now we don't need the z, and technically that z output is going to be incorrect because a procedural terrain is constantly changing the scale of the z. And it wouldn't show up correctly anyway. So we want to ignore that. So we're just going to create a very simple function here. Right click once again, add a math node, vector operation, and let's use Composer 3. This will combine 3 different numbers to create a vector. So we also need something to break down the size vector. Right click, math node, vector operation, decomposer 3. This takes a vector and splits it into 3 numbers, so separating the x, y, and z. And we need one more decomposer, so math node, vector operation, decomposer 3, to connect to the existing size. These top 3 nodes, position, orientation, and size, these input nodes, are the current position, orientation, and size of the object. So what we can do is link it to itself for the z-axis. And we'll see that in just a sec. So the Composer 3, we have input 0, which is x, 1 is y, and 2 is z. So we'll connect input 2 to our decomposer 3 that's connected to the self size, the current size of the cube, and select the z. The input 0 and 1 we can connect to 0 to the x of this other decomposer and y. And now we can take this decomposer and connect it to that external dependency, which is the procedural terrain size. So now when we connect the size to our Composer 3, combining the x, y, and z from the self size, which is also an open scale, and we'll be able to modify that independently, and the x and y, which are now linked to a procedural terrain. This will not work with the standard terrain. Standard terrains exist in a different vector scale within graphs, and will cause a huge size difference between the objects. I do have a tool that I created to compensate for that. So if you own Snowflake, one thing you can do is load in the terrain size linker, which will compensate for the scale difference, because the scale of a standard terrain, and often sometimes even a procedural terrain, but for the most part, a procedural terrain except the z-axis is correctly linked to other objects in the scene. Standard terrains are based on the pixel dimension. So this allows you to type in the pixel dimension, and when you're using procedural terrain, you can type in the size manually since it is constantly changing. And then also set up a few other size modifications. This will allow you to link a standard terrain or another object and equally have the sizes correct between graph links. Without it, It is a little more of a complex setup to create that. So I did make a tool that makes it a lot easier. So now the graph is set up, we're going to have an exact size connection, and also it locks in the x and the y. So I cannot modify the x and y scale of this cube because it's directly linked to the procedural terrain. I am going to undo this action I'm about to do right now, but just to show you what I can do is just change the size of that procedural terrain, and then you'll see it modify the scale of the cube. So they are directly linked. We have an exact scale. So what we want to do is take the procedural. So we're going to edit procedural terrain. Keep in mind the mapping mode, which is object parametric, and we can right click on the altitude production function, copy the function, click OK. Select the cube, and now we have our material, which I reset. We're going to double click, and I'm going to give it a new name just in case the other one is called material. Just call it cube. And under the color and alpha mode or tab that we have up here, we can right click and paste the function. We're also going to set that mapping mode to object parametric so it matches the procedural terrain. Now this isn't going to be an exact match just yet. There's one more change we need to make because materials and procedural terrains work differently from the function editor. The way terrains are generated, and if we just go ahead and take a look at the terrain, even though the display is a 3D view of the function, it isn't. What it does, it takes a slice of the current vector and then extrudes it. So if we switch this to the 2D plane mode, we're going to see what's actually showing as part of the procedural terrain. It takes a slice from the fractal, in this case, since we're using a fractal. Whatever function you're using, it'll just kind of slice out from the origin and then extrude from there. Materials, however, because they exist in the complete 3D space, the fractal moves through them, and your output is going to be a little different. Now, if this is matched its scale correctly and the Z position, then no other modifications need to be made. But to make sure that we have just that slice, what we need to do is remove the Z-axis from that function. Now, because I reset the material, we have the black and white that we need. And I'm going to edit the function, and all we need to do is modify this vector. And what we want to do is right-click, add a math node. We're going to go to Vector Operations and select Matrix Transformation. This lower right output is the Z. Right now it's set to 1, and this is adjusting the scale based on the position, the world system, or object system, really depending on the mapping mode. What we want to do is set this to 0. And now we can connect the seed that we had created. The seed is an origin change from clicking on the new button in the procedural or the terrain editor. And what it does is modify that seed setting. So that was carried over. Because we have a multiply and seed value, we do need those to match this terrain correctly. And now we have this matrix transformation where we're nullifying the Z and might actually need to put this below the multiply. I'm going to reconnect the seed to the top and now connect the matrix transformation below that. And we're going to see the overall shape of this change because of that. And I am going to try that once again with this matrix transformation above. When you're working with the seed, it does change the way this works. If you've generated something completely new where it doesn't have the seed and the multiply, uh, then it's always going to be an exact match using this method. So it does look like we did need to have that above the seed option. So having it below did generate a different shape, but we can now see the slice that is generated from the terrain. And what we can do is now set the camera to render this object, keeping it within the bounds. So what we need to do is change to a square render mode. And now this resolution you can set to whatever you want. The ratio will need to be the ratio of the terrain. Since we have a square terrain, we could just use square. But if you did modify the scale, you will need to find out what the change is, set up an aspect ratio so you can lock it in place and render it correctly. So what we can do is switch to the top camera and you can line it up with the cube, keeping it within the bounds. Now, what I suggest doing, because matching this perfectly takes too much time and isn't worth it, what I suggest doing is making sure it is just within the view. Give yourself a little bit of an edge, and then when you're finished rendering, you can edit the image and just cut out just the cube surface and not worry about the rest of it. Another thing you could do is if you own Snowflake or the Metanode Collection version 1, you can use a linker which is Terrain Previewer Camera Controller. And what this will do is lock the aspect of the camera to any object in the scene. This is set up to lock to terrains. There is a switch between standard and procedural because of the size difference. And then there's a couple of different tweaking options just because there is no direct top view render available in View. It is based on a focal, which means there's going to be distortion. What this does is puts the camera really, really far away and zooms in. And that way it removes as much distortion as possible. And then you can line up edges as well. I'm not going to worry about setting that up. But if you just keep the terrain or the cube within view and just give yourself a little bit of a border to make sure you're not cutting anything off, it should be fine. Now, we do need to make a few modifications to the material and also render settings. If we go back into the cube's material, now if you're using version 7.5, you can turn on Ignore Lighting and Ignore Atmosphere. You also want to turn off Cast and Receive Shadows, Indirect Lighting, and Anti-Alias really doesn't matter, we're using a cube. We can turn that off, so that way we don't have to render that out. If you're not using version 7.5, you're using version 6 or 7, or even version 5, or, sorry, not 7, versions 5 or 6, or actually, yeah, version 7 up to 7.5. Then what you need to do is take the loom value and turn it up to 100%, and then you can turn down the diffuse and the ambient, and that'll give you the same result. So that is also possible. The highlights you'll also want to make sure that you have turned off if you're going to do this without version 7.5. What I'm just going to do is ignore lighting, ignore atmosphere since I am using 7.5. We're also going to see the exact same output within the preview render. And all we need to do is render it out and we have a displacement map. Another thing you can do to make sure that you have as little material distortion as possible is to select the terrain, and what we want to do is take a look at where the pivot location is. What we can do is move the cube closer to that. Since we have the object parametric mode turned on and we're not using a world, moving this around will not change the fractal. So we don't really need to worry about aligning that too much. But I do want to take the Z scale and shrink it down as small as possible without actually removing it entirely. You could also go up to the top to the numerics tab, select size, and just take that Z, and that's at 0.001, and that should be ready to go. We'll just adjust and zoom in, move the camera in a little bit more because of that scale change. And that'll also help prevent any additional edges showing up. Another more helpful method is to zoom out a little more or move the camera back a little more and then use the top camera focal zoom option to zoom in, and that will remove more distortion. So all you have to do now is select the size you want to output. This will also render very quickly. So using a very high resolution is suggested, and no problem at all. So you could set this all the way up to 6,000 by 6,000 without a problem. Once you hit the higher resolutions, basically anything beyond 3,000, 4,000, you want to make sure you're using the rendered disk rather than rendered to screen. I'm going to go ahead right now, just really quickly. I'm going to render this out higher afterwards, but just to set a smaller resolution right now, actually we'll just go ahead and do 1000 by 1000 rendered to screen. We can see how quickly that renders the fractal, and you do want to make sure that you're saving this as a 16-bit or 32-bit image to get the most detail out of this as possible. So using the same techniques as I discussed in other parts of the training with the Z depth, basically you want to apply that same principle and same idea to this image because we're working with a grayscale, a fractal, and we want to get as much detail as possible. So what we could do is save this as 16-bit TIFF, or you could use HDR or EXR format, and then have a really nice displacement map, something very versatile for export or use within the program with directly in view still in order to create different material maps. Or if you need something height-based to work with as a matte. And that way it renders much quicker than the standard procedural terrain or standard terrain export options. You don't have to generate a really high pixel resolution terrain. It's just this very quick transfer over. So it's a big benefit using this method. And just one last note, and that is we're using object parametric mode, so the vector position doesn't really matter since our cube is offset. But if you are using the world coordinate mode within the terrain editor, world mapping mode, what you need to do is modify the graph further in the cube and adding in an input node external dependency, take the procedural terrain's position and connect the cube to that position, which means you'll also need to, in this case, move the camera. Now, because of the procedural terrain distortion and size, we might not be seeing the cube perfectly. So we can take that procedural terrain and just hide it from the scene, and I also have it hidden from the render. But now we'll hide it from the OpenGL. And the cube is also, at the moment, below the ground plane. So what I want to do is just turn off the ground. Or at least in the OpenGL, it's below it. And now we can render this. So if you're using the world mapping mode, this will make sure that the material is in the identical location as the terrain. And that'll help match it up better. And there is one last note about rendering that I want to make, and that is if you double click on the top camera, make sure you are using absolutely no post-process effects, no natural film response, no auto exposure, no post-processing whatsoever. What will happen is uh, the natural film response will create an inaccurate output, and the auto exposure will cause some issues. So in order to get an exact displacement map that matches the procedural terrain, do not use post-camera effects whatsoever, none of them. So just make sure all of that's checked off and that your exposure is set to 0. I also want to note that in the material for the cube, and basically just what we had transferred over, if we go and edit the function, since we are controlling a color, and this will typically expect an input between -1 and 1, what you can do to make sure that there's no oversampling is open the function node preview, and in the fractal, if you are going above 1, and you will see with the extension what the highest point is. If it's above 1, you need to turn down the gain. If it is a more complex function, you need to take that output and add a filter to reduce the gain amount to make sure it is under 1. That will properly map the black and white correctly. So if we didn't just have one fractal overall, and we need to reduce several fractals being combined together, we can add a filter, switch this to gain, and now at 0, it is going to completely destroy the output. And as we move up higher, you can see it is increasing the overall extension amount. So just use a very small amount and just kind of bring it down a little and make sure that it is not going outside of a value of positive and -1. We can also do really quickly is adding in a filter. You can edit, and on the right, if you're going above 1, you can bring down the right side of this filter, bringing down the overall output. And if you are going below -1, you can bring up the output. Another method to do this, which I'll show really quick, is to have the color map black and white, creating a color map. And if you can see, the upper clamping mode is set to clamp, which means once you go beyond -1 and +1, it will cut off the detail and nothing will be shown. If you mirror it, then you're going to get some repeating amounts and it's not going to be correct. Repeating will also do the same. So clamp is kind of required, but you can also connect to the color output and control an image map that way. So that way you're generating actual color for this output. So you just want to pay attention to that. And I just wanted to make that last quick note to make sure that your displacement maps are showing up correctly. Most important is definitely the camera post-process, but I mean, if the gain is too high, you're going to have spots that are completely white. So if I increase the gain, what we're going to see is a maxed out white value and no detail will be there at all. So you do need to decrease values and make sure you are in between a number output, -1 and +1. If you find that the image you create directly from the procedural, having the entire height, doesn't have enough detail for a normal map or bump map, depending on how it is you're using the normal map, For something that's tangent based, you would want a little more detail locally for each individual normal. What you can do is modify the fractal a little bit more to decrease the gain amount. And I am going to open the node preview just to pay attention to our output. You can decrease gain and increase the roughness setting. Now you can see that the more we increase roughness, the higher our output will become. But as long as we can stay within the value of -1, +1, we can create a really nice output. And also keeping in mind the roughness settings will get very grainy if they go a little too high. If you notice too many large spikes, and this window can be scaled to a fairly large amount. You can also zoom in and out to see the total detail. So this way you can adjust it and modify these settings in order to get a little bit of a rougher render to work as an overlay or anything else. So if we take a look at how this render is going to show up, and the more detail you have, you will probably want to turn on anti-aliasing for the material. And check that option on, maybe increase the render quality, sometimes even a matter of going in and setting up some user settings. Because as we can see, this is pretty grainy. Within 16-bit or 32-bit image, it's going to look a little bit better, because of course this is an 8-bit preview. But this way you could add an extra bit of detail overall and have a separate map, maybe as a layer. And for another variation, you can also remove or take that matrix transformation and set that value of z back to 1. Which will overall change the initial major shape of the fractal, but can work as a nice overlay that will match, for the most part, the overall roughness settings and shapes that are built into the fractal itself for larger scale values. Also, when we zoom into this, you notice JPEG-like artifacts and seams. Now, whether or not this is caused by rendering to the screen and the temporary preview, I'm not quite sure. Rendering it to the disk should remove any of those artifacts if that is the cause. Another solution is to render larger than you need to and scale down the image. Since these do render very quickly and are network render compatible and multi-core, so it's not connected to those export functions which only render on one core, it's definitely a possibility to use a different resampling and render sometimes even twice as large, and then reducing the scale. To really dramatically speed up render time for creating these types of maps and renders, there's a few user settings we can set up to really increase the speed of these renders. So if we right-click, go to the render options by right-clicking on the camera preview, what we can do is set the render settings to user settings. And what we want to do is turn off subrays, super sampling, and under the advanced effects quality, we're going to select custom settings turn off adaptive sampling. We're not using any indirect lighting, so that is fine. We can save it in that way. I'm just going to turn up volumetrics, even though it shouldn't impact the scene at all. We don't need to worry about photon maps because we're not rendering any indirect lighting. We can turn off optimize indirect lighting on plants. And then we're going to turn off object anti-aliasing, turn off always render lights, and turn off use automatic scene hierarchy. Now, the always render lights option, you might want to keep on if you're using a different lighting method to generate this image, where if you had the output connected to the loom value and you're not using ignore lighting or ignore atmosphere, another potential setup I just want to show really quick is you could add an output node, select the luminous option, and connect that to the fractal, and the color you could set to a constant color of white. Of course, we do have to connect the color to that output, but this will also work to run through the loom channel and produce a similar result. So that is also an additional possibility for the connection. I'm just going to disconnect these options from the loom, put it back on that color channel. And since I have ignore lighting and atmosphere on, we don't need to worry about the loom value, but whenever you disconnect that output, it might change the loom value to an amount you don't want. But let's take a look at the render speed. And now this is 2048 by 2048, and the render is just flying. It's going extremely fast. So really quick, I'm going to set this to 1000 by 1000, render it, and you're just going to see it blaze across the render, go really, really fast. And now if we set this to, say, the final mode and render, it's going to take a tiny little bit longer. If we went to the ultra setting and rendered, it's going to take even longer. So turning off all those settings, using a user setting just purely for this purpose to render out, you can render some gigantic frames and really have the option to adjust the scaling and not have to worry about render time because it's just so quick. There's not even a need to send it off to a network render farm even if it's a scale of 12,000 by 12,000, just because it goes so quickly.